Now it's time to look at the linear phase multiband, which is abbreviated to LinMB in the plugin lists. Now, as far as this interface is concerned, it probably looks a little bit familiar to some of the things we've already looked at. This is a linear phase multiband compressor, not a limiter. So it's not a brick wall final stopper, it's a multiband compressor. And what this gives us is 5 discrete bands with lots of control within each band, all with linear phase crossovers, so there's no smearing or distortion caused by crossovers, and a whole bunch of other features. So let's have a look over the interface. Now, not dissimilar to the L3 limiter, we've got these crossover points here, which show us where the frequencies split off. So by default, 92 Hz, 545, 4K, and 11K. And as usual, we can click and drag on these by hand there, or we can pick up the actual dividers on the GUI as well there. Now we've got all these settings here, and they're all separate per band, but there's also a master control here that can move them all at once. So for these thresholds, for instance, I can grab this one and bring that down there, and you can see that arrow moving there. I can also grab it by that arrow and move it. Or if I like, I can grab the master for that particular parameter and pull down here, and all the thresholds will dive down that you can see. And it also works relative. So say this one here is already down a little way, and then I grab the master, it will keep moving down and the others will move outside of it, so they don't equalize, which is good. Push that back. Next up is the gain. So just like the limiters we've looked at, you've got independent in-band gain, and you can see the GUI responding to that. So I'll reset him. This control here, the range, is an important one. Now, this is a compressor, but it doesn't use the conventional compressor terminology of ratio that we're familiar with. So you have to think of things a slightly different way here. The range tells us the amount of dBs that the compressor can attenuate. So this default setting here of -6 is saying that the most it can attenuate, no matter how low we make the threshold, is going to be 6 dB. Now, if we make that higher, let's say now we take them all down to a 12 dB potential attenuation. This will unwittingly affect the ratio of the compression, but we never actually get told now you're doing 3:1, 4:1, 5:1 or whatever. It's actually a product of this range control and also this knee control that we're going to play with later. But we have to kind of get our head out of the mode of worrying about what the ratio is. And the next two controls here are familiar to anyone who's ever used a compressor, just the attack and release, but they're totally separate per band, which gives us great control. Now down here we have a solo and a bypass for each band, so that lets us fine tune things really easily. So let's take this track for instance and say we want to hone in on the bottom end where it might be a bit boomy and we just want to bracket that area. I could solo that and quite easily dial in that area. Right, so we might be happy with that and we're back in. And then I can treat that separately. And of course this readout here is fantastic, makes it very easy to see what we're doing. So the orange line is like a virtual EQ that's dancing around, or a dynamic EQ. So that lets you see exactly what the processor is doing, and at the same time you can make judgments visually as well as with your ears as to if you're hitting a certain band too hard. Before I jump onto the next thing about range, just have a look at this thing working really hard so you understand how this display works. I'll pull down a lot here. Right, so you can see the orange line responding that way and pushing down. What's probably not immediately apparent is that you can also push up. Now, by default, this range parameter is into the negatives here, but it can also go into the positives. Now that can really turn things on its head and it's very powerful. So I'll put these ones here. I'll maybe use these mids because it's easier to hear. And I'll leave these ones like -12, that's fine. I'll take this one and put it +12. And the same over here. Now what's going to happen is as the threshold is crossed, in a traditional compression sense, as the threshold is crossed, this guy's going to push up and these frequencies are going to push down. So here we go. Now at the same time I can bring these gains down just to make it a bit more even frequency-wise. Push this gain up even. So I'm focusing on the orange line, trying to get it as straight as I can, let's say. Bring that one down. Not too far there. Right, now let me bypass back to the original track. So despite doing something pretty crazy, you know, it's not that far off where we started. I'll make the threshold work even more. Okay, bring this down. Bring this one back up. This poor top end's really copped it. And bypass. Okay, so I'm not trying to make it sound particularly good, obviously, I'm just using extremes. But you can see, looking at this curve now, that's our starting point. So again, a very, very versatile performer in terms of some of the acrobatics you can do with the audio if need be. So I'll reset that and we'll look at the other controls now. Now here is dither. Now we saw this on the linear phase EQ. So once again, this plugin's operating at 48-bit resolution internally. So in the case of my workstation here, Pro Tools HD, it has to output a 24-bit word at the end of its processing. So in my case, I want the dither on, and in most cases you're going to want the dither on, and that's because this plugin will then dither its 48-bit word back to a 24-bit word and then hand off to the next process, be it the mixer or another plugin in series. Now the only reason you probably wouldn't want that on is if your particular host is operating 32-bit clean. Now that's not all native hosts, mind you, but some of them apparently, I don't actually know which ones, will pass off a 32-bit signal to the mixer or to the next plugin. So in those cases, you want to turn the dither off, but I think those workstations are rare. So if yours is handing off a 24-bit resolution signal, then leave the dither on and you'll be fine. Now the next one here is the makeup. Now it defaults to manual, but it can also be auto. Now auto makeup is like what we've already experienced with the L series limiters, L2 and the L3, L316. When you pull down on the threshold, the track itself gets louder as you pull the threshold down, unless we pull it down using that link control, as we were several times. But natively it's actually getting louder. So let's just have a demo here of what normally happens and what the auto can do for us. So I'll go back to manual, and just for the example, I'll pull a large range here. And now let's play. Now as I bring the thresholds down, I'll grab them all at once. Right, the track gets softer as it's getting compressed incredibly hard there. So we'll reset that. But with the auto makeup, what will happen is gain will be applied as I pull down, and gain will be applied evenly over all 5 bands. So here we go. And the display will change too. See, now as I'm pulling down, the display's going up. I'll keep going. Right, now I'm compressing like crazy there, but yet the volume hasn't changed. I'll bypass. So we've certainly changed the sound a lot, but the actual raw RMS power is similar. So from your perspective, just choose whichever one works for your workflow. The good thing about this too, by the way, is that even if everything's all skewed, it will still work. So let's bring that back down to 0. And, you know, I'll just do something crazy. I'll go -8 on there. I'll go +8 on there, and -12 on there. So a really crazy shape. Now as I pull down, everything gets maintained. So any work you might have started will remain intact as you move on to this workflow, which is great. So I'll reset him. Now we'll move on to this third control here, adaptive. Now this is an interesting one. I actually generally do not use it. I leave it in its default state of off, and its movement actually, if I move from here, is off, and then it starts at -90. So this is in decibels, -90, and it goes all the way up past 0 to +12, sorry, as we saw there. There we go, up to +12. Now what this has to do with is the effect that louder sounds have on softer sounds, and the masking effect that occurs because of that. And so what's been proven is that loud lower frequencies can mask the effect of soft higher frequencies. And sort of takes a moment to get your head around that. But if you've got bass booming, let's say, or down in this area here, if this fella's booming here, and there's soft information in this one, this loud information here can really affect the way we perceive the soft information over here, to the point where it actually masks it, and our brain interprets this information as being even softer. So this adaptive control here tends to address that by lifting the threshold of the band above the one that we're talking about. So in this case, look, I've got all 5 bands set to smash pretty hard. In fact, to obliterate to smithereens. But again, just for the example. So I'll just play a little now and you'll hear what I mean. Right, so I am smashing all 5 bands here. They're being slammed down. Now what I'm going to do is raise this adaptive control and watch what happens on the orange line here, which is showing us the frequency response that we're getting. Okay, so I'm going to start lifting this. And when I get to around here, watch the upper side. A bit more. Right up at this end. Here we go. Now watch the upper end. There we go. It's starting to, the very lowest one is still doing what it's doing, but the ones above it are starting to lift. And here we are up at almost 0 now. And what's happened is the thresholds in these bands are actually being kind of artificially, by the algorithm, artificially brought up, so they're not compressing as hard. And that's going back down again. Now to make this a bit easier, let's reset that and that and that. So we're only playing with these bottom 2 at the moment. And I'll bring that down to off, and here it is naturally again. Right, so of course it's very shrill and trebly because these guys are up full. Now watch what happens as I bring up this adaptive control. There we go. Now this band here is starting to give some back. Down, up, or let's put that guy back at 0 and slam this one. Put the adaptive back, sorry. Okay, so now these 2 middle ones are being slammed. Lift up the adaptive. And there it is again. It's giving a little bit back here. So as I said, this is not a control that I would usually change off, and it can get pretty techie, but it's a good thing to maybe go back and read the manual and see what they have to say about this whole kind of masking process and how our hearing can be tricked and affected in that way. And there can be some clever intelligence going on with the algorithm if you use this control. Because for instance, if the bass is hitting hard, it'll give a little bit back here, but then let's say the bass in that track backs off a little bit and this band isn't working as hard, then neither will the artificial threshold boost on this band be hard. So they'll kind of work in tandem in that way and go back and forth and look after each other. So that's the adaptive control. Now next up is the release choice, and it's defaulting to ARC, which as we've said is Wave's automatic release control, which is adaptive and works in real time on the program material. And the only other option there is fully manual. Now in this particular processor, the distinction is in fully manual, it's 100% following what these settings are. With no intelligence being applied, it's just those numbers exactly. But if you put the ARC on, unlike what some reports have said, these figures are not completely ignored. They're still very much adhered to, but the ARC acts as kind of like an overseer and makes various decisions on top of what's there. So these release times are kind of a guide, but a very strong guide. So the ARC kind of comes along and just makes on-the-fly adjustments as it sees fit over the top of that. It is a very successful system. I mean, unless you're going for something artistically kind of a bit on the outside of things, it's not like the ARC is going to come along and do something that's going to bother you. It's really working for you and not against you 99% of the time. So I'm very inclined just to leave that on all the time and then adjust my releases here for the general shape that I'm after. Okay, next up is the behavior of the compressor. And the choices there are electro and opto. Now opto attempts to work like the optical photocell compressors that have become famous over the years, whereas the electro one here is actually Wave's own invention, which attempts to almost be a polar opposite to the way the opto works in terms of its release time. The differences between these two pivot around the 3 dB of gain reduction mark. Opto compressors have a very typical release behavior of what's known as putting on the brakes as the gain reduction approaches 0. So if you're hitting something really, really hard, the opto compressor will recover very, very fast, but as that recovery gets closer and closer to 0, and we're going to use, say, 3 dB as our pivoting point here, the release slows down as the gain reduction gets closer to that 0 point. So this is really good if you're compressing quite hard because it's nice and fast at those deep compression points, but then gently slows down. So it's kind of a very forgiving kind of compression sound. Now electro, on the other hand, is kind of the exact opposite. So above that 3 dB of gain reduction, so when you are hitting quite hard, it actually has slower release times, and then as gain reduction approaches 0 again, it speeds up and gets very fast in that last little section there. So the benefits of this are when you're compressing in a kind of a moderate to quite high level, it can maintain really good RMS average level. So this is if you're trying to get things kind of loud, you don't want it bouncing back too much. You can maintain that thickness to the sound without the compressor shutting down on you. And only then when you're getting close to that zero again does it speed up and clamp down for that final section. Now all this talk is kind of easy, so let's demonstrate this and see what it looks like. So the first thing I'll do is zoom in on a snare hit because I've got a little idea of what I want to do here. And I'll just check that. Actually, no, let's get a nice snare. Right, okay, just something like that. Now I've saved a little preset, which is that one there. Now this is smashing it really, really hard just so we can watch. I'm just going to hit play and stop very quickly so we can watch the release of the compressor. So as you can see, I've got these set really high, like 1.3 seconds all across the board. So it's a very, very long release. ARC is on, but we can try it with it off as well. And we're set to opto now, so let's see what happens. Right, now just watch around here as it comes back. I'll go again with opto. Right, so it's very, very slow when it's deep out, and then it kind of clamps down at the very end. Right, now let's go to electro and have a look quickly. See, it's a much faster release in general, but it's much slower at that outside point when things are getting quite deep. I'll go back to opto. And it's faster on the outside, but slower on the brakes part at the end there. Now let's turn ARC off, though I've got a feeling it's probably not adding anything anyway. So we'll go back to electro. And opto. Yeah, very similar results. So the point still stands. They're your two choices, and obviously, depending on the style of music and how aggressively you're attacking it, you'll know which one to choose. Now the final control here is knee. Now this refers to the knee of the compressor. It's going to be the same across all 5 bands, and the knee of the compressor dictates the aggressiveness at which the point of the compression kicks in, so to speak. So if you've got a hard knee and you have a threshold set to say -10 dB, maybe at -11 or -12, there will be no sign of compression, and then as soon as you hit -10, the compression starts immediately. If you've got a softer knee, it's more forgiving, but it's kind of got a wider reach. So that threshold set to -10 might actually start compressing at -15, even -20 if it's a really, really wide knee. So it starts gently though, it doesn't start at the full setting. But you know what, it might be easier just to show this on a graphical display. I'll pull up the default DigiDesign compressor that comes with Pro Tools. And if you can just observe this small display here, I'll make the ratio higher so it's a bit more aggressive there. Right, now we can see this orange line here dictates the threshold, and the knee is where it turns from this diagonal line into that line. Now as you can see now, it's a hard knee, it's a hard turn at that point. If I adjust this knee control, keep your eye on that point where it intersects with the vertical orange line, and you can see that it softens and it becomes more rounded. So now as the signal flies up here, the onset of compression will be more gentle and it comes on more gradually. And the other extreme being back at the hard setting where it's like no compression, no compression, no compression, bang, maximum compression as per your settings. So just understanding that's what the knee is. In here now, it defaults to 0.5, which is a midpoint between hard and soft. So if I go down to the bottom, I get soft. Up the top, I get hard. And so that default is a good starting spot. But if you need your compression to be more aggressive, I'd be using the hard setting. And then at the other extreme, if you wanted something a little bit more seamless, a little bit more kind of easy onset and invisible, I'd go for the soft one. So the default in the middle is always a good choice. And I seldom actually find myself moving from that anyway, but the options are there. So that's all we've got to say about the LinMB, or linear phase multiband. And next up, we finally break away from processors that begin with the letter L, and we move into max volume.